Okay, so this is our green sensor network currently. So right now it consists of 3 Arduino Nanos hooked up to breadboards. Over here are our 2 sensors, and this is the aggregate node. So on each sensor there's a microphone that is being used to pick up noise, and a transmitter module that is being used to send data over to the aggregate node. So on the microphone this pin over here all the way to the left is being hooked up to VCC, which is 5 volts on the Arduino. The middle pin is being used for ground, hooked up to ground on the Arduino, and the rightmost pin is out, which is hooked up to analog 1. And for the transmitter module, it is just gotta make it a good angle. So rightmost pin is being hooked up to ground on the Arduino. The middle pin is VCC, which is also hooked up to 5 volts, and our data line, the leftmost pin, is connected over to D12 on the Arduino. And then on the other sensor, it's basically the same setup. The only difference is that we also have a battery hooked up to it, which is being used to power it without having power supplied from the computer, which is really nice. So for the transmitter module, hold on, let's get a good angle. So the leftmost pin is 5 volts, which is hooked up to the 5 volt pin on the Arduino. The second from the left is hooked up to D12 on the Arduino for our data, and the rightmost pin is hooked up to ground.
So on the left side here, we have the code for the transmitters, the 2 transmitting sensors. It takes the outputs from the sensors and goes through the analog pin 1, which is basically an ADC converter, and converts it to a digital code for transmission. On the right side here, we have the code for the receivers, or the one receiver. It takes the binary code that's in the string array that is in binary code, and it converts it back to a string array for the monitor to output. And so far we have our output for the 2 sensors. So for us to determine which voltage value is coming from what sensor, we differentiated them by using the letters A and B. So far this is reading the peak-to-peak voltage values of what is being inputted to the microphones.
So one of the changes we've made from our initial design was the inclusion of antennas. So we've got this copper wire, it's 22 gauge, hooked up to the transmitters, and it gives it a much better range. Before we were getting something like 3 or 4 feet, and now we're getting more like 10 to 15 meters. As far as stuff that we need to do still, we have this LCD screen. And we've kind of tested it a bit, but we need to get it working, and at the end of the project we want to convert our voltage values to decibel values and display it on the screen. Also, we were thinking about implementing op amps to increase the microphone range, because it's not very big right now. One of the changes that's going to happen sooner is we're going to find a better collision detection system. So we've thought about this a little bit, and we're thinking about adding a transmitter to our aggregate node, and then that would talk to a receiver on each of the sensors. And so in that way, we could have the aggregate node tell the sensors when to start sending data,